Okay, the last topic is rational functions. So this unit is two big parts. Radicals, we're done with that. Okay, everyone's good? Radicals and now rationals. Two completely different things. Okay, what is the non-permitted value? Yep, in grade 11 we talked about this. In a fraction, what's the bad thing to do in a fraction? What doesn't work? We don't like to do an over 0. So what's the non-permitted value? 2. X equals 2 is the not permitted value. Non-permissible. Okay. Some of you might just see it, but if you don't, you could go this equals 0 and solve, or you could GCF. What is the number I don't want? 5. If x is 5, 2 times 5 is 10, 10 subtract 10 is 0. Okay, next, what's the non-permitted value here for x? I might be doing a trick question on you. 1 is fine, because 1 squared is 1, 1 plus 1 is 2, and that's okay. What else are we thinking about? 0? 0 squared is 0, 0 plus 1 makes my bottom 1, that's allowed. Negative 1? Negative 1 squared is 1, 1 plus 1 is 2, that's all good. What are we getting at? There's none. They all work. Okay, so here's the idea. What happens when you square a number? It's either 0 or positive, right? There's no way you can square something to be negative. In other words, I'm trying to make that be negative 1. And will that ever be negative 1? Can you ever square something to be negative 1? No. So everything is permitted. Okay. Next. What's not permitted on this one? Can I make you do something like that? What do you want to put in those spots? X plus 3, x minus 3. So what are the non-permitted values? 3, negative 3, they're both not allowed. Okay, and the last one, I'm going to make you do this. So we're going to factor that. So what do we have? A 7 times 2. So x is not allowed to be 7 or negative 2. Okay, when you have something like this, it will create a vertical asymptote. The non-permitted value, if x is not to be that, it's going to create an asymptote there. Unless this happens, where that cancels something the same on the top, and it will create a hole in the graph. Okay, so when something cancels, it will create a hole in your graph instead of an asymptote. So those are the rules with the x values.
What does a hole mean?
It's like you have to skip over it. You're like going on your graph. Oh, I got to skip over that spot.
If it were to go like in the direction of what, there'd be a blank spot.
There'll be a blank spot, yeah. Yeah. And you might see this written down for a fancy name. Point of discontinuity.
Is that what we're going to use?
If you're talking to me, you can use a hole, but I'm thinking when you read your provincial exam questions, you might see the language, a point of discontinuity. Well, that's what all your workbooks are, exam questions, yeah, yeah. So when I write it, I think I often, you might see me write POI, and that's what I'm talking to about. POI is the point of, oh, PO, why did I write I? POD, I guess. POD. Okay. That's the rules. That's half the rules. Okay, we're going to shift to the other half the rules. So now let's talk about horizontal stuff. So what's happening with our y's, our horizontal asymptotes? Okay, this equation is a what degree? We just learned this unit. What's the degree of this equation? Like, is it a quadratic? Is it a cubic? Is it a quartic? It's cubic. It's a degree of 3. That's the highest. And the leading coefficient is a 2. Okay, here's the 3 situations. If the degree is higher on the top, so if you have a higher degree on the top, what happens in math when your top number gets bigger and bigger and bigger? Your number will get bigger, bigger, bigger. Your number is just going to get bigger. So if your number on the top is going from 10 and in the bottom would have been 2, and then all of a sudden it's like 112, and then it's 1,000 with a 20 on the bottom. You're just going to be getting bigger. Okay. Next rule. Here is a situation where my degrees are the same. So this is a degree 1 and this is a degree of 1. They're the same. Then you're going to have a horizontal asymptote at some number. And to get that number, you're going to divide the coefficients. So, specifically for this example, I would have done y equals 10 divided by 5. So this one would have a horizontal asymptote at 2. Okay, and then the last is what if the degree is higher on the bottom? What if the degree is higher on the bottom? Do you see this one is higher on the bottom? The squared on the bottom? Okay, I want you to think about if your bottom of a fraction gets bigger. So example, 1 over 10, 1 over 100, 1 over 1,000. Let's just pretend my bottom is getting bigger and bigger. What is happening? You're getting smaller, 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 smaller. What number are you actually just getting really close to? 0. So when your bottom of a fraction gets bigger, you are actually getting smaller, 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 closer, closer, closer to 0. Okay, that's it. Now you can do anything. Those are the rules. So, ready? Recap. Look at the non-permitted values. It's either a vertical asymptote or a hole. Assess the degrees. There's either no restriction, divide the coefficients, or 0. So you have to memorize that. Okay, number 1. First step. Give me the factors of the bottom there. So x plus 5, x plus 3. What numbers am I not allowing x to be? I don't ever want a -5 or a -3. That's not good. It'll cause my bottom to be 0. Oh, but wait. That would cancel. So, at -5, I'm going to have a hole in the graph. At -3, I'm going to have a vertical asymptote. And what's going on with our degrees? Are they higher or somewhere, or are they the same? Higher on the bottom. So what was the conclusion? If the bottom was bigger, y equals 0. Okay, so I'm going to do the asymptotes already. So x equals -3, y equals 0. Okay, now I'm going to make some points. So this is what we had. What happens after I've canceled that? Do you know what the top would be once something's canceled in math? 1. Okay. You know what I think we should learn to do first? I probably should have had this. What's the coordinate of the hole? -5, comma, what? Can you plug in -5 into that for me? What is that actually as a number, as a fraction probably? -1/2, because the bottom's -2. So -5, comma, -1/2. Can you draw me an open hole like that? There's going to be a hole in the graph.
Why did you put the word half down?
So this is 1 over, and then the bottom is how much? Negative 2. So then I just say that as a number, as a negative a half. Okay. Let's do a negative 6 and a negative 4, and then once we have a few points, we got the shape. Okay, can you plug a negative 6 into this? 1 over, what is negative 6 plus 3? Negative 3. We already did this one. That was the whole. Negative 4. 1 over negative 4 plus 3. Okay, so 6 comma negative a third. 4 comma negative 1. Negative 6. Okay, so I have those 3 points. And do you know what we do with asymptotes on a graph? We follow along them, right? So I'm gonna shoot down that one, and then coming here, I'm gonna be flattening. Okay, let's do a couple of points on this side. So, ready? Negative 3 plugged in. Oh, that was that's the asymptote. So we're not going to do that one. Negative 2 plugged in. 1 over, what's the bottom? Negative 2 plus 3. 1. Plugging in a negative 1 makes the bottom 2. And when you plug in a 0, the bottom would be 3. So I'm going to plot those 3 points. And what do you think? Do you see the pattern? It's heading up, and this way it'll be flattening. Okay, you can never ever ever cross over an asymptote. So if your graph is making you, that means you did something wrong with your points. Okay, let's look at the next one here. Okay, let's talk about non-permissible values here. What's not allowed? I don't want a negative 1. That's not allowed. So do you know, will it be a vertical asymptote or will it be a hole? As in, would this cancel with anything on the top? No. Even if I did factor this, which I don't need to right now, but if I did, nope, nothing's canceling. So negative 1 is a vertical asymptote. Whoops, why did I write that under the... Sorry, I wrote that under the horizontal by accident. Vertical asymptote. X equals negative 1. Okay, horizontally, let's talk about the degrees. What do we got going on? Higher or same? Higher on the top. So what does that mean again? If the degree is higher on the top, the number just gets bigger. So there's none. Okay, so now what I will do is I'm going to pick a couple x values on this side and a couple on that side. You can do 2 or 3 depending on if you understand what's going on. so let's plug in -3. Ready? -3 squared is 9 minus 4. -3 plus 1 makes what? 5 over -2. So -2.5. Ready? -2 squared is 4. 4 minus 4 is already 0, right? Because the top is 0, so I don't care about the bottom, it's just 0. So let's graph those. -3, comma, -2.5, -2, 0. You know what? Maybe it's not a bad idea. Let's just do another one here. -4. Okay, -4 squared is 16 minus 4. So I got -4 in that result. Okay, so that's that side. Now let's pick out some points on the other side. I'm plugging them in. Ready? 0 squared minus 4 is -4 over 1. Now plugging in a 1. Equals -3 over 2. aka -1.5. And then plugging in a 2 makes, oh, I'm going to get 0 out of this. Okay, so 0, -4, 1, -1.5, and 2, 0, which means it's going to kind of look like that. Okay, we'll do one more, I think. Okay, let's do one more today and then we'll call that good. Okay. Tell me what's my non-permitted value. What x number is not good here? 1. Will it be a vertical asymptote or will it cancel and be a whole? It's an asymptote. So x equals 1. Okay, so there's the vertical asymptote. Okay, talk to me about my degrees. Higher or same? The degrees are the same. So what do? We divide the coefficients. What's the leading coefficient of the top? 5, because 5x. What's the leading coefficient of the bottom? 1. So y equals 5. Okay, pretend you didn't see my little table over there. Which x values would you want to plug in on this side of the asymptote? I'm going to go 2, 3, maybe 4 if I can't see it. So I'm going to plug in a 2 and a 3. Okay, ready? Are you okay if I just do these fast? When I plug in a 2, I get 10 over 1, so 10. When I plug in a 3, I get 15 over 2, which is 7.5. Can you graph those? So 2 comma 10 and 3 comma 7.5. Do you have enough understanding to know what it's going to look like? You can do another point if you want, but I can tell how it's going to shape because my asymptotes. Okay, I'm going to go with a 0 and a -1 because now I'm going to the other side of the asymptote. So 0 plugged in makes 0. And this makes -5 over -2, which is 2.5. So 0, 0, -1, comma 2.5. Okay, do you have enough understanding of what the shape will do? It's going to be going down there and then a curve and flatten. And this is it. So you have to go through non-permissible values, asymptote or whole. Degrees, where's my flat line? Is there no flat line, a 0, or a number? And I'm going to go back to this first example and let's just quickly do the domain and range of it. And then you know everything there is. Okay, ready? My domain, I'm going to be -infinity. Then what's the x value that I have to skip over? -5, round bracket. Because I got to skip over the whole. Then I can continue. So -5, I'm traveling along, -5. Oh, there's another x value. I have to skip over -3, round brackets. Then what? I can continue again, -3 to infinity. This is another way I could have wrote it. X can be any real number except for -5 or -3. Okay, range. Our graph goes down. So -infinity. As you're moving up this graph, where's the first height we have to skip over? I have to skip at the hole. What's the height of the hole? -0.5. Then from the hole I can continue all the way up to 0. And then once I hit the height of 0, I had to skip that. And then I can continue again. Y can be any real number except -0.5 or 0.